So also very warm welcome from my side to the Vector Conference 2024 here in Seoul. It's also a great pleasure for me to be here today, having a chance to give the keynote speech on the smart way to design SDV. So let's start with the presentation. My talk covers the status quo and gives an outlook on the necessary technologies, architecture patterns, processes, methods, tools, and I want to focus also on collaboration opportunities, because this is, from my point of view, one of the key assets and topics where we as a SDV community have to focus on in the next months and years to be successful in the overarching journey. And here we want to give today especially the perspective from Vector in my presentation, but I want to enrich also my presentation with my more than 20 years experiences at different OEMs. So let's start where we are coming from. G1 has already mentioned the four main objectives which are still valid, so shared, personalized, automated, connected and electrified. These objectives were pushed also with new technologies. Some I have highlighted here. Software ecosystem for sure, all about CI/CD. So the cloudification is very important. Having at the end a fast integration and test processes, and then for sure all around safety. The big step for us as automotive industry coming from a fail-safe design system where the driver is still the last fallback to a fail operational system, like what is implemented already in the avionic industry for the autonomous driving cars in the near future, so with level 3, 4 and 5. And to do that, a lot of basic technologies are necessary, especially for the high-performance computing platforms, mixed criticality systems, and something like that. And doing this, from my perspective, especially new know-how in the companies is necessary. Also, new working structure, new organizational structure. And as I mentioned before, partnerships. And this is where my presentation will deal with. So let's start with the look back, or also look on the status quo. So from my perspective, especially when I take a look back in my former roles, also especially during the founding phase of the Cariad in the VW group, the idea of the OEM is to invest more and more in software, taking also integration responsibility for the key ECUs. So when we take a look on the future architecture, it's the zonals and the HPCs especially, then they have to focus on the heterogeneous software development processes. So in former times, we have dedicated ECUs at the OEMs. Each department has its own integration and testing procedures, and this have to be changed when we are talking about high integrated computing platforms, where all deployed functions have to be developed in the same manner, based on the same processes, having at the end the possibility for full automated CI/CD pipeline. And then also the mind change or the know-how change, that the engineers at the OEM are very often still in a supplier management mode. So these engineers have to also get the capability to get more and more understanding in software development, the processes, coding guidelines, and something like that. On the other hand, when we take a look on the supplier side, they have also to think about, due to the shift, role shift at the OEM side, the tiers has also to change. So how they can provide hardware without software and the way around software without hardware, and how they can support in the best way the OEMs in a system integration. In addition to that, new players are on the market for sure. So they come with a lot of very deep IT software experience, but to implement at the end software in an automotive context, a lot of additional topics have to be considered. So the safety stuff, the cybersecurity, and something like that, to have at the end full homologated enabled system approach. And as G1 already mentioned, the hype cycle. So from my perspective at the moment, and I like the picture from my appreciated colleague from Bosch, Matthias Pielin, very much, where he said last year at the ELIF conference in Bonn, there are two journeys at the moment seen at the market at different OEMs. So the one, they want to do everything by their own, and the others were doing step by step in the direction of a software-enabled car company. And I think this is the key lessons learned, and also the task for us as software SDV community, that we have to think about the integration, testing of high-performance computing platforms. How does it work? How we can enable our engineers on the supplier side, on the OEM side, also with the universities, that they get the right knowledge to be well prepared to bring SDV to life. And that's also a lessons learned from my personal journey. It's very important that we have not to do everything by our own. We have to work in partnerships to be at the end successful. So how does it look like? So for me, the big picture looks like this, starting with the architectural view. So we have for sure the hardware architecture and the software architecture on top of it. So for me, it's very important to have a layered approach. So no longer a distributed architecture solution, what we have today in the cars, more or less. So coming from the vehicle platform up to the sensor actuator layer, then the zonals, which are decoupling the specific car relevant solutions with the high integrated computing platforms on top. And then on software side, you need a good scalable software platform. Then I call it extended services. So for example, an environment model for the data fusion of sensor, radar, and these data, and then an application framework which enables at the end our software developers, the application engineers, to focus on the application development without having a deep knowledge on the software platform which is underneath of that. And then for sure bringing the vehicle stuff close to the cloud. And this enables at the end the same what we have already in place with the CE devices. So when I take my Apple iPhone, I can get the iOS update or weekly updates for my dedicated apps, or I can change the whole iPhone and can update the new one with my old stuff from the old one, additionally with new apps. So the release cycles at the end are quite different when we take a look on the car, and these release cycles can be covered and enabled based on this layered architecture. So on top, on the application level, I have a very short release cycle phases, and underneath, especially for the chassis and mechatronic systems, where I have longer development cycles and not so much changes and updates. Here I can decouple the applications from this world. And to enable all of this, and this is for me the core asset from a technical perspective, to enable a software-defined vehicle, we have to consider 5 core topics. So, as I said, the most important one, a software platform. Then we need an architecture blueprint with considering hard and software. So we have here also to think about hardware, the SoC strategy, software platform strategy, and also about the software logistic at the end for the update mechanism. Then we have to figure out, especially on the part of the here in this area for the HPCs, so how an ecosystem for high-performance computing platforms looks like. So in the past, we have addressed a lot for the ECUs in the AUTOSAR context, but for the high-performance computing platform, the auto standard is not enough. So here we have to sit together also as a community to enable here the further additional solutions. Then we have to talk, as I said, about collaboration models, the platform bring up, and for sure then we need at the end a software factory. And based on these 5 topics, I want now to go a little bit more in detail on each of one. Let's start with the first one about the software platform. So when we take a look on the status quo at most of the OEMs, they are mainly focused on the car development. So the car platforms are in lead, and underneath there is the software and EE development for the dedicated car platforms. So the software platform is not in lead. You have reuse, but only based on so-called carryover parts, which drives then to have a lot of legacy at the end in your system. And for the future, from my perspective, the SDV approach have to look like this. So we have a software-driven development, including also the electronic parts with dedicated release cycles of the software platform. So the software platform at the end lead the whole vehicle development, and underneath then the dedicated vehicles can use the dedicated releases of the automotive software platform or operating system from the dedicated OEM. And this can also use then for new vehicles, so for the first SOP, but also in the same manner we have then the enabled capability that the software can be used as an update container for vehicles which are already at the customer side. And this is for me the key success factor. So here we have to discuss about the update capabilities, how the software factory looks like, how I can reduce the branching, and how does a lifecycle management of my whole software logistic looks like. So these are the key topics in this area. In addition to that, as I said, the architecture is the second key factor. And here I want to take a look from two perspectives. The one is more the topology view with the dedicated ECU classes. So from our perspective, there are at the end 4 ECU classes in place in the topology of a car, starting from very small sensor actuator ECUs, then dedicated control ECUs, especially for hard real-time systems, especially in the powertrain and chassis domain, and then the so-called zonal controllers and the HPC platforms at the end for the whole applications, for the vehicle, the ADAS and IVI. But here also a trend, what we see is that there are no longer the functional separation what we have had in up to date. It's more that we have to talk about so-called capability domains, so where we can cut the functionalities in safety critical and fast startup systems in safety relevant functions which have a high performance need, and only QM based applications like the IVI multimedia stuff where only high performance computing is necessary. And based on that, to do this so-called shift north, we have to consider the dedicated requirements concerning the safety and homologation relevance, for example. Also the update frequency, what I have mentioned before in the on the other slide. Real-time capabilities, the performance, also the variant dependencies, so how the functional cohesion can be figured out, and also the hardware agnostic, so that the applications have to be more or less hardware independent as far as it works. Then when we go a little bit more in detail, so the second view on the software platform perspective, here once again, the abstract topology of a car, including also the clear connection to the cloud side. And here, from our perspective, scalable and modular software platform is one of the key success factors, starting at the lower end for the small sensor actuator ECUs, where we have the micro-SI I/O technology as a lightweight implementation of I call it lightweight IoT automotive stack. Then for the control and zonal ECUs, the real-time platform based on the micro-SI classic solution. And then in the mid part, all about the HPC stuff with the micro-SI adaptive, with dedicated operating system, hypervisor solutions, and also very important, the interconnect to the dedicated ADAS and IVI stacks like Android or the NVIDIA or Qualcomm systems. And then the end-to-end solution to the cloud. So this is also quite new for us from Vector side, that we are working or offering end of this year the first cloud solutions also, so that our customers have the opportunity and possibility to have so-called end-to-end solutions, integrated solutions for OTA, so over-the-air update, data collection, and a lot of more applications at the end. But as I said, today the main focus for my presentations in the next on the next slide is especially the HPC stack. But because this is, from my perspective, one of the key working points where we have to focus on as a community, and so let's dig a little bit deeper in this part. So to have at the end ecosystem in place, what we have already for the classic ECUs based on the AUTOSAR standard, here we have to sit also together and think about what is necessary from a development framework perspective, but also from a tech stack perspective, so from a concrete technical implementation perspective. And when we take a look on the HPC stacks, we have, as I said, the three pillars. The one is the generic vehicle applications for body control, powertrain, chassis, and so on. Then the dedicated ADAS and a dedicated IVI stack. For ADAS and IVI, there are already a lot of solutions in place. I mentioned some before. And then we have to figure out how the HPC stack have to be realized to consider especially the real-time safety and high-performance requirements. And here the idea is to build up in a community approach all around the IDE, consider the dedicated programming languages. So from our perspective, it's also important to consider Rust as one of the new and upcoming promising programming languages here in this area as well. So not only C. And also to think about what kind of building blocks do we have already in place based on the adaptive AUTOSAR standard, and what we have to enrich in addition to that in such kind of ecosystem that we have at the end a full-fledged, a full stack approach for dedicated applications which can be developed based on C++, Rust, and for sure also other programming languages. So here the key objectives, so we have to define this ecosystem, so some kind of a architecture building block plan, and then we have to think about also as a lessons learned from the past that only specification is not enough, so we have to work closer together on a code first principle basis, so that our development teams, OEM, supplier, and tier overspanning can work closer together. And to do this, from Vector side, we are working currently on a collaboration approach based on code first, so that we have at the end the possibility to consider different sources which can be maintained based on an open source project, but also that we will open up our repositories of our stack, that we can collaborate directly with our customers based on our solutions, on our stack solutions in a community-based development approach or a partner development approach. And for sure, for some part, it makes sense to safeguard the IP where closed development is still valid, the right approach. And based on that, at the end, we can then provide a full SDV stack as a distributor, and providing this then to different OEMs. And as I said, the OEMs have the possibility as part of this team that they can collaborate and work directly in open source based projects together with us. So for example, we have just started a working group in the Eclipse SDV together with BMW, Mercedes, and ZF to implement a first step on the application framework. And as I said, we will open up end of this year our repositories so that our customers can contribute also directly in our adaptive and classic solutions. And in addition to that, we have to collaborate, but it's also very important to ensure that the stuff will be standardized at the end. And this is also very important for us as a community. So from my history and take a look back, I think the AUTOSAR approach was very successful for the classic part. And as I said, for the HPC ecosystem, we have to do something quite similar, but using also the lessons learned what we have had. So especially we have to think about the code first principles instead of specification only. We need clear responsibilities. So at the moment there are, from my perspective, too many consortia in place. So therefore we need some kind of a strategy and a definition phase, and then a clear dedication, especially with focus on the cost first principles. So for us, the Eclipse SDV is one promising step, especially for hosting projects, using this as a pre-specification and as a collaboration platform, so incubation space for new missing parts of the HPC stack. And then as a second part, the communities and partnerships. As I said, we open up our repositories, and then the other part, the standardization part, so with Covesa, especially for the APIs, so for the API catalog of the vehicle, and the standardization for the overarching software platform for the base layer. From our perspective, it makes sense to use further the AUTOSAR standard to do this. So this is the perspective for the ecosystem from our side. And now let's dig a little bit deeper also in the collaboration mode. As I said to the beginning, the roles are changing. So when I had in my last role, I had also the integration responsibility for the new platform in the VW group. And one of the most critical point was that we have too long integration times for the ECUs, and this was mainly driven that there is a staged process, so tier 2, tier 1, OEM, and then the way round, and therefore the roles are changing. So as I said, the OEMs want to take over more integration responsibility. Then on the other hand, based on that step, the tier ones have to think about what is their future role. Won't they provide complete platforms, so pre-integrated platforms, for example, or software or hardware parts, so being more tier 1.5, for example, and also very important. So when I take a look on our role as Vector in some dedicated projects, so for example with Mercedes, we are working close together, so in a direct manner. So together with Mercedes, we make the bring up of the MB OS platform, for example, and this lets at the end also that the former tier 2s have to rethink also their roles, rethink their capabilities. So we have to take a look on our organizational structure at Vector, that we be ready to doing such kind of projects directly in contact with the OEMs. And for sure, as I said, there are also the new companies, new players which have been also considered. And this is the point and the experience, what I want also to share with you. From my perspective, it doesn't make sense that an OEM is doing everything by their own. To be fast and to having at the end a robust and especially a standardized software platform, it makes sense to make partnerships, to collaborate in areas where an open collaboration with partners makes sense, but also in a bilateral manner, it's very important to share know-how, to use know-how from the dedicated companies, and this is, from my perspective, one of the key assets and points what we have to consider to be successful for the future implementations of an SDV. How does it can looks like? So two patterns as a proposal. The one is, so for me, it's very important having a good collaboration between the software platform partners. So, for example, we as Vector have to work close together with the SoC companies to make a good and to offer a good and pre-integrated reference implementation of our stack based on an NXP, Infineon, or some other devices to the OEM, and the OEM can then focus, especially then, on the platform integration with the support, for example, from our side. So the way what we are doing together with our colleagues from Mercedes, for example, and the OEM has then the chance to focus with his capabilities and with his teams on the customer relevant topics, so the application development and for sure for the full system integration. So this is the one pattern. The other could looks like, so I said we have to think also what can be the role in the future for the tier ones, so that there is a system platform partner in between which take over the system integration, the platform integration role. And this as the second pattern. So just before coming to the end, how could it look like in detail? So for me it's important that we have a platform strategy which considers on one hand the software platform and also to have a good reference implementation. We have to sit together with the OEMs and the SoC companies. What is the SoC strategy for the dedicated platform at the OEM, so that we can then make the first integration step for the platform, so having some kind of a reference implementation. Then the dedicated, based on that, the dedicated implementation of the dedicated ECUs in the OEM context. And then in the fourth step, it makes sense to bring the dedicated applications on that. So this is also the lessons learned from my former roles. As an OEM, you are always very curious to see the functions running in the system. So you make the big bang, but at the end you struggle so much because you have failures from the infrastructure side and also from the application side at one time. And based on this staged approach, you can reduce that and have a robust platform running when you start the integration on the platform side, and at the end, for sure, the full-fledged system integration. So to do that, all the software factory, which is also a very important part of our today's conference, so don't miss the presentations and the discussions outside with our colleagues today. I think this is also a very important asset to implement a good software factory with the dedicated DevOps tools, to think about what can be contributions from partners to the dedicated OEM software factory, and how does at the end the full-fledged CI/CD can look like. And coming to the end, so the SDV portfolio from our side considers three pillars: the software platform, with the dedicated implementation, the software factory with all around the building processes, the design patterns and dedicated support, and also very important advisory and supporting services, so that the first two pillars can be implemented in the best way at our customers. And these topics are addressed here on our conference today, and please discuss with our colleagues, think about how we can support you in the best way. I think this is the way we can be successful together, having at the end successful implementation of the SDV. And summarizing my presentation, so the first key success factor, as I said, is a software-driven platform approach, so that the software platform lead is the lead project at the OEM side. Then zonal-oriented layered EE architecture with a scalable and modular software platform, and a well-defined API framework that at the end the function developers can be more or less independent, develop their applications. So in the same way what we have already in place in the IT and CE industry. Then the ecosystem, especially for the high-performance computing platforms, but also considering the cloud side with the dedicated consortia and responsibilities. And for sure, we have to think and define clear roles in the collaboration between OEM and the suppliers, and especially with the focus on code first, so that we don't have long specification times. So fail fast is important, and for sure at the end the robust implementation of the software factory, that everything is running well in a automated manner. And this are the 5 success factors from our side. And as I said, I'm happy that we can share our solutions today with you, discuss with the colleagues today, use the time here, and now I'm happy and open to your questions. Thank you very much.